by using autoencoders concept. Okay, that is one way how people can do. But what I suggest, don't simply take the existing neural models and try to run out some data such that what you will end up with some minimum classical accuracy and you are done with the solution. No. Okay. Try to add with various optimization algorithms, some bias per feature optimization algorithm, and add the features to the input layer of the deep learning. Then run on the existing models, existing data sets that you can see. Now, in this case, you can go for contrary. I mean, when you add new optimization algorithm or use some existing better optimization algorithm and feed the features to the input layer of your deep learning model, then you can use even the same data that was already used by somebody on similar network where the feature extraction was not done. Right? I'm just telling how the preliminary research in deep learning can be started. Those who are willing to do research in deep learning, you can call the existing deep learning architecture, run on some new biological data, and show. So you are addressing a new biomedicinal problem, something like that. May not be biology, any other data where the similar composition was not done. Take a deep learning paradigm, run on some new data. So that's a kind of new application or new solution you are making using the existing deep learning architecture. There you may not have any novelty, maybe in the deep learning architecture. Okay. After that, on the other side, when you make some kind of optimization of the features in the deep learning model, then you can run on the existing data which was already used combined with some other deep learning architecture, but this time you get better classification accuracy. The reason is you added some advantage of extracting better features and preloading to the input layer of the deep learning model so that you will have better classification accuracy. Are you following me? These are all preliminary research that you can carry in the deep learning architecture. Similarly, all existing data, fractal net, ResNet, SpeechNet, and other generalized adversarial network, and all other type of network. First, you run on the conventional data sets. Try to make some changes in the deep learning paradigm. You can propose new aggregation activation functions, or you can preload the input features taken from some bias for application algorithm, and you can attempt to minimize the number of error layers, and so on. So attempts you can make and combine with some recent, you can say, real-time biological or biomedical data sets or any other type of data sets. Then you will have a good publication out of this. Okay. But when you want to make a theoretical contribution to the deep learning model and using some application, then you have to dig into further how to design efficient, how to say, functions or efficient feature extraction or efficient so on and so models. Some of the researchers, what they do, they try to propose some novel aggregation functions to the deep neural networks and all. If you see in the figure, we have a kind of novel aggregation function. This is a kind of multiplicative aggregation function. What is the novelty in this function? It's a kind of what you can say weight optimization. It's a kind of connection you're trying to establish between the weights and feature values. But what type of novelty that you can add to the aggregation function? If you see in the figure that you have what we have rho ij. What is this rho ij defines in the novel aggregation function? That is the multiplicative function we have here. This rho ij actually defines a correlation between features x and x. So when you have the feature correlation here, the features that are highly correlated, you can combine and you can ignore the other features, and you can go for the features that are not highly correlated, and you can extract such features rather ignoring the repeated features of same kind. So when you are one way you can decrease the number of features, other way you can select the highly accurate, or you can say more generalized features with the help of which you can find the better classification accuracy. I'm just telling this is one such example where you can add some what you can say some kind of dependency or some kind of correlation between the feature values, and accordingly the weight updation can also be happened during the intermediate layer of the deep learning architectures also. Can somebody hear me? Please confirm.
Yes, sir. Yes, sir. Yeah.
Okay. Thank you.
Yeah.
So this is the other way. Like in the previous slide, I mentioned you can use some biome-squared or any nature computing or any other optimization algorithm to extract better input features to the deep learning model in the first layer of the deep learning, and then you can use them some real-time data and so on. So on the other way, you can use the existing deep learning as it is, and you can run some data set. But typically, they are not considered as a theoretical contribution. Again, don't quote me. And then similarly, you can propose a novel aggregation functions and activation functions with the help of which you can certainly they will direct the notion of the classification and of course computational efficiency also. Even weight optimization becomes easier, and then the aggregation of weights and these feature values and everything becomes easier with all these contributions and all. Compared to the previous slide contribution which I mentioned, when you can propose a novel aggregation or activation function, or even some include aggregation function also, it's a kind of theoretical contribution you can always make out in your deep learning architectures. Okay. Now coming to the various other aspects of a deep learning model, what type of applications we can have? Typically, when we talk about some image processing related application, let me just go through for 2-3 image processing application. Then I'll go to other type of NLP related applications and all. If I go for simple classification problem, image classification problem. First of all, I'll go for what? Some image or you can say object detection, then segmentation. Okay. If you understand, object detection is harder than classification. Simply detection, you can say, is harder than classification. But you can perform by this extensive training of that. And the reason here is when you have large amount of feature samples available, and such a complex image is given to you, where when you are making such a prediction, like whether there's a cat or dog is present in the object, then what type of features you're going to extract and use it to make the matching of the given class to be identified with the help of the similar objects available. If we say detection and segmentation, there is a difference. You might need segmentation, of course, in the detection process. But just with segmentation, you can't detect the objects in the particular given image using by calling your advanced or conventional deep learning algorithm. I'm going to call particular some deep learning with some assume that some 10 hidden layers. Okay, I have multiple objects are traced out. Now, whenever they have similar features available with the help of the different object tracking, sometimes it may not be so easier to make such an extraction or such a separation among the objects that are identified in the segmentation. Therefore, detection task is harder than classification. You can assume that simply because your segmentation is a kind of classification of perform. But whereas detection is not so easy, you require further training and further learning to be happened after segmentation is done. Okay. So one of the solutions, of course, I do not say it's a very advanced problem of detection and segmentation. I'm just starting with the basic problem first. I'll go to the other problems, of course. Now, like object detection, segmentation, it's a conventional problems where you try to address upon first on large amount of data. Then you try to improve to other set of mode like what you can say object manipulation, or you can use from CG applications, computer graphics application. Like in the figure, there is one dog or cat is shown there, and the particular image of this one can be converted into the other features, such that what you can manipulate the image. Such a type of detection can be useful, and then of course eventually the segmentation is part of this type of detection. So these type of typical image related operations could be performed or operated with the help of a deep learning architecture, but there is an extensive training is needed because real-time objects are seen in the picture and contour segmentation and level by level image segmentation you are making. Therefore, you require to have a large amount of training on similar objects pattern classification. Okay. Similarly, image colorization is another tough challenge in your image processing domain, where you might address with the deep learning architecture. For example, the first column shows the input image given to you. Am I audible? Okay. So the first column shows the input image given to you, wherein the second column, the image that was what you can say colorized with the help of your model, maybe led by some kind of fractal net or any speech net or Bayes net or any other type of CNN with some GLCN features or any other type of conventional or any other type of deep learning architectures, wherein we are trying to colorize the image with the help of given input image. So this is my input. This is the image produced or manipulated, or you can say extracted by the proposed method. But actually, the actual image is like this. The third column. This is a real-time image, and wherein you got this image, black and white image, and you need to colorize the image something like this. So what type of if you can see there is a clear distinction between the extracted or resultant image from your deep learning model and actual image, where the input image is a manipulated image given to you, whether it is a security application or some defense application or it could be anywhere. But it would be such a complex task, and you need to understand. Now, tell me how to do such a type of what you can say extraction of the actual image from the manipulated image. Third column is the actual image. First column is the given image. Second column is the resultant image from the given image. Then how to make such a type of colorization? You can easily sense the application and all. Even in a defense application also you can have. Okay, so it's not a, the application is obvious here, but how to make such an application to be fulfilled? Now, if you see the second column, what you are, how this particular deep learning architecture taking this image as an input image. If you see the top column, top row, you have got image of a deer, and then you are trying to use your deep learning model and trying to extract some particular correlation between the pixel values and these what you call your intensity values, and then try to make some correlation. And according to, for example, see all the background image, or it is a background of the image, that is the grass. Okay, they have similar correlation of the feature values with respect to their intensity. Then when you take similarly the horns of the deer, when you take the horns of the deer, they have different intensity values, and where you try to find the correlation, maybe using some novel aggregation function or maybe any other aggregation function, where the feature values are extracted based on the correlation. And then you try to combine these particular what you can say feature values and then make same color to them. Now, which particular color to be there? If you can understand, there is a clear distinction between second color and third color, but more or less we are almost close to the third color. So the kind of training you have given to the deep learning architecture and the kind of testing you're performing onto this one based on the training data, and then what type of feature correlation you're trying to extract from the particular given image to make the actual image based on the developed model. That's very important. So image colorization is another particular basic scope that you have in your deep learning. Okay, and don't think it's obvious, sir. And don't think it is used for simple application like this. This can be used for defense application or any other type of application and so on. When you combine such a type of image colorization or any other thing with some what you can say image emotion classification, are you following? Based on image, when you classify the emotions, and when you combine this type of image colorization, and when you go with this type of detection, when you combine all three, you have wonderful applications. Okay, I'm going to give them later on. Then similarly, this is the photorealistic transfer applications where you see this is even tougher problem for your deep learning architectures when you have some input data. As you see, first column is the original image. Second column is the input image, or you can say reference image. You can say whatever it is. Okay. First column is the original photo that you can call as the input image. Second column is the reference that also you can call as the input. You can say input 1, input 2. And your job is to make the what you can say reference photo in the form of an original photo. That is known as photorealistic application. Are you following me? So if you can understand, I look into the image first image, the image in the first column, and I will refer the image in the second column. I will try to combine the features of these two. Okay. Then what will happen? I try to add the features of second image, the reference image, in the first original image. So it's a kind of what you can say an agreement you are making between these two images, and then contracting and then making these particular images. It may not be just color. It may not be just color. Maybe other features also to be added. Okay, shading, or even you can say the intensity levels and everything. It's not just a color you are manipulating. So these type of photorealistic effects or applications, okay, are very useful in particularly something like your CG applications, computer graphics, animation, and these 3D virtual images and so on. Okay, and sometimes I can make a photorealistic applications, style transfer applications with respect to the what you call 3D images also. Okay, I have one reference image is a 3D image, and I have original image is a normal image, and I want to convert the original image into a 3D image. If you must have seen how some old black and white movies have been converted into color movies. Okay, even they started working on this converting existing movies into a 3D image. Okay, kind of effect you can have. So these type of photorealistic applications using some neural networks or conventional deep learning architectures in your image processing, they have extensive applications. They are used and they have huge market. This type of, because you see why people don't go for such what you can say that CG related movies and all is because they're very expensive. They're very expensive to shoot and make such a type of effects in your original film. Therefore, people want such a such a, I mean, there is a large requirement to make such a photorealistic effects and so on. So using the deep learning architecture, and they are very expensive. I'm telling you. Okay, and of course, this is not very advanced one. This is simple example of that. How it can be used for a 3D image analysis and some kind of CG applications for some other type of models. Okay, so where you can use your deep learning architecture. Here, how you can use your deep learning architecture? Tell me. Here, tell me. Simple. Here you observe first. First, just use train your neural networks based on the first image. Catch up the features. What are the features that could be read by the deep learning architectures for the image one? Then image two, reference image take up the features. Okay. Then see how to preload these particular features of the reference image to the original image. First, for that you have to make the feature classification first. What are the features? What are the type of the features? Then how to load these features there. Then how to make the weight optimization there. Then when you combine them, then you are going to make the original image. Then into a resultant image. Okay, into a resultant image which contain features of the both. Or you can call one particular deep learning with the training on the image one, other some convolution neural network trained on the image two, and then try to make a hybrid network including these two, and so on so. Then you can find a final resultant image with reference to the second one and the features are of the actual one, something like that. Then another important challenge in the research, challenging research in deep learning or image processing with the help of deep learning could be object removal. If you can see again, this could be extensively be used in computer graphics and other CG movies, and then this type of applications. Okay, if you see the first column is the original image, where the second column is the input image given to you, and you have no idea about the original image. Okay, this is the original image. This is the input image after deleting the object. Your job is to make the output image such that as if like there is no appearance of the actual object that was removed from the original image. So you are doing only input. So is it not a kind of prediction you are making behind the background of the what you can say missing objects, kind of prediction and some kind of training and construction? You are actually making image construction here. It's very, very important. Object removal is also needed image construction. Because when you remove an object, what is behind the object, you construct such that as it appears like there is no object present in the actual place where the object was removed from. Okay, this is again a very good application for mainly for animated movies and other related applications. Not only animated movies and if you can understand, we will some biomedical application also you can use. If you can take a 3D ultrasound image or whatever it is, some MRI images and all. Take such images and see if there is a tumor present or any other polyp or something like that. Then see that and see the structure of the particular organ as if like it is not there, and what is the extension of the particular tumor up to what level, and try to see if it is eliminated and what are the contours and the connections that are to be happening in the organ where the tumor is going to be deleted from. Are you following me? And even you can make a tumor prediction also in the early stage when you are going with such a particular MRI images and try to extract the objects and say whether they're benign or malignant tumors. Okay, so object removal requires image construction also partially. Okay, so they all could be easily be implemented or achieved with the help of a advanced deep learning model. It could be maybe a fractal net architecture or a SqueezeNet or ResNet or any other CNN with GLCM or your generalized adversarial network or any other type of deep learning models. Okay. Similarly, image completion. Now, if you look at this thing, this is almost like same. When you go for the second image and third image, you are making image completion. When the second image, one thing is missing, and the third image you are trying to add that. So this is actually slightly a variation of that. Try to see. Now I am not going to, you see this middle image and the first image. You are given with the middle image and you are going to get the first image back. Are you following me? When you are given with the middle image and you are going to the third image means your object removal and reconstruction of the background images. Okay, that was not captured while taking the image. Wherein when you are doing the second image, can you come back to the first image? That is very challenging. Like as if like you are going back to the what you can say past. I have given the second image. Can you come back to the first image? Not so easy because you are traveling back. Okay, it's something like a theory of your theory of relativity. It's kind of example like that. Okay, so here I don't have input image now. If you see, assume that there is no input image, there is no second row is given. Assume that there is no second row is given. Your job is to construct the second row. Your job is to extract features such that what? Based on what? The neighborhood pixel values. And how do you train the neural network based on the neighborhood training value? First of all, you have to understand the locations or the intensity of the pixel values where you are going to construct the image. So this is a kind of image construction you are making again, but you are going back to the past. So there was an image given, you are going to construct the original image. How you make the original image? So first so you take this particular set of images. You know the original image. You know the manipulated image. You don't give the original image. You give the manipulated image. Train your deep learning model and find the better feature. Now, tell me what are the features here? Tell me which are all the features here? Here the features are nothing but first of all, you have to identify the contours, the segments in which you are going to predict the suitable pixel values for the image portion. Because only then you can understand what are the surrounding features of such a type of intensity pixel values. Then you are going to train the neural network with the surrounding pixels, with the help of which you can understand what could be the proper what intensity for the pixel value at this particular location, and so on. Okay. So it's a kind of what you can say image construction, or you can say image prediction. You can say something like that. So this image completion technique challenge is very challenging. Image completion. Can I use for some defense application like a photo of a terrorist or somebody captured in a particular image, some CCTV footage, but it's not very clear. I can use some sharpening or denoising images such that the photo could be somewhat clear. That's fine. But still some portion of the photo is missing. Assume that in the something like the last image in the first row. Am I audible? Somebody confirm, please.
Yes, sir. It is audible.
Okay.
Yeah.
Now you see the last image in the first row. Image of a boy whose face was masked. Not masked in the sense it was not properly captured by so and so reasons. Now, can you make image completion technique using some generalized adversarial network, some GAN models, or some fractal net, some speech net, some glaze net architecture? Can you combine the features of some GLCN with some particular deep learning architectures in image processing? Then can you extract this? And what is the guarantee that he is a person? So first of all, you have to train your model based on that and see how much accuracy you have got based on this, and so on. So, okay. So image completion is even more challenging compared to this object removal. Okay. But when you have given the second image and going back to the first image, is kind of same, but it is different. You are giving original image and then input image. Then you are going to the output image, something like which is the reconstructed image as it appears that the object was not there. Okay, but image completion is even more challenging task. Many of the PhD students used to work on this one, image completion technique using some advanced deep learning models. Okay, and people have got around 85–90% accuracy almost. Okay, but the challenge changes when the features value changes, when the image changes, when the type of the image changes, and such a type of image completion is even more difficult in 3D image. Okay, 3D images that is even more difficult. And similarly, when you have when you are trying to develop deep fake network, there are some because nowadays there are many fake applications where people are starting using to manipulate the objects or images and try to develop for some real-time application, or you could say to just manipulate the objects like this and make some sentiment analysis or any other type of application. Therefore, you can design some deep fake after build some feature values and see how it can be exploited. Okay, this type of what you can say image manipulation techniques, or you can say image dealing techniques, could be easily be addressed with the help of deep learning architectures based on some. Again, features are very important here. How you optimize the features, how you extract the features, and that is very important. Okay, and another important application is multi-domain image to image translation. That's very important. I will give one image of a particular person. You see the first row, so only see row wise, don't see column wise. Okay. I have an input image. Now I have some predefined features. Okay, predefined features. Now whatever the feature selected accordingly, the input feature is modified itself such that I may be able to see this one, the desired features. And it's very important to understand such a level of feature extraction to be achieved. Are you following me? So it's a kind of now if you can see, if whenever such a type of multi-domain image-to-image enhancement is possible, you think this type of applications such as TikTok and what you call any other type of applications we have, they could be even more popular, such that you need not make a TikTok video. Simply upload your particular image, just upload your image and select the video, and the particular image and video can be processed together, and such that the resulted video could be in whatever the emotions are there in the video, that will be shown with your face as a front image. Okay. So you need not to give any expression or emotions there. You see the kind of evolvement that will happen in a multi-domain image-to-image translation techniques when you try to develop the real-time database architectures. Are you following me? So when you make such a type of architectures, that will work for what you can say multi-emotional image classification applications. Certainly, you will be able to make even the applications such as TikTok or any other application to be evolved like anything. Okay, but this type of applications is not so easy because they require a lot of complexities within the image processing, and then what you call your feature dealing, and then your any other problems that will be raised. Okay, and similarly prediction models based on image, like you take a input image based on some time, something like winter image captured in winter, then you are going to make some your AI generated summer image. So in the summer, coming summer, it could be like this, a prediction I'm going to make. It's a generated image. Yeah? Similarly, what you can say, you take a input sunny image and how the rainy image could happen for the same image. You can make a prediction. Now, how to train the neural model here? Tell me. You take the input winter images of last 10-20 years. Then you are going to train them not only with respect to time factor, but also with respect to other conditions that could possibly arise in the particular geographical location where you are going to taking the data from. You have to take the weather forecasting data, AWS automatic weather station data, remote sensing data, satellite data, and another. Not just the image by image prediction. How do you make it without any other parameter? Take a sunny image, take the AI generated rainy image, so on, so did this could be the possible so also, and take the weather data, other atmospheric data, and take the original image data, and take the rainy data. If the temperature is something like this, if the rain is something like this, how the image could be look like, so on so. And similarly, your image to image translation. Now this is even a different problem. I have some. Don't think that I'm giving all example image processing. I have some other example also. Just a moment. So when you talk of this image to image translation, it's not so easy because this is the original image you are taking, and that particular image, based on that you are trying to generate different image. Something like based on cat image, you're giving the copper image and cheetah image, leopard, lion, tiger, based on one object. So one object you're completely changing into different manipulations, right? So this image manipulation, or you can say image, what you call your extra image, not exactly manipulation, I can say image updation. When you try to make based on the input image, these unsupervised learning techniques, when you are trying to select, you should be very careful that what type of features you're going to consider for each of the image which you are trying to convert with the help of the input image. Okay. Again, this first you have to understand what type of classes you are going to follow with the help of the input image, and what type of alterations you are making in the image with the help of the feature intensity values and so on. So then which class you would like to follow. Accordingly, you have to do the update the weights and feature values in the deep learning architectures of the layers. Okay. Similarly, we have a deep learning and NLP. How the NLP can be used with the help of a deep learning architectures like that, and then what type of problems you can. You can make a classification in deep learning. You can make classification of this also. Language detection, I can detect the languages. If I give audio, simply I can train my deep learning model. What based on the audio, what you can say, feature values. Okay, audio feature values, the bits. Okay, that are noted as their input features. I'm going to train the neural network and see which it exactly matches, what type of, what you can say, synchronization, and some lexical analysis you might require to make the classification with respect to language detection, and your sentiment analysis, and then authorship detection, something like that. You're going to make some particular paper and going to see some, maybe some plagiarism detection and so on. So many other applications. And then some other e-commerce application, like finding the prices and dates and reviews extraction and so on. So then language modeling and how to make some lexical analysis on to make language modeling. And if I give a particular word after sentence, it will have different meanings depending on the previous sentence. So how the modeling of the language can happen based on some deep learning approaches. Then how to extract some key speeches, key phrase extraction. That is very useful for sentiment analysis. I'm going to give as an input last 1 year newspaper data, text mining. Okay, text data. So first of all, I'm going to extract all the key phrases. When these key phrases are extracted, the phraseology you will see, and based on the phraseology extracted, you are going to understand what type of features you could possibly phrase it into, and then what type of conclusion you make for some sentiment analysis. Then finding some synonyms. What would be the possible synonyms based on some understanding and some lexical relation that have multiple sentences in a particular para or a book or a chapter or so on. Then your machine translation applications and other so on. So question answering and some reviews application, feedback, dialogue systems, and all other applications. There are a lot of application in natural language processing using your deep learning. Okay, but what type of data for training should be given carefully, because then other multimodal learning models, we have image caption generation, and we have already seen video describing. Something like I'll give a video, you are going to make some annotation or quotation, whatever it is. Then visual question answering, I'll give some images and some text, you have to answer something like that. Some speech recognition based on some lip motion. You have an image where the voice is not there, based on some simple lip motion, you are going to identify. Similarly, and some image classification, navigation. So some kind of basic for some navigation techniques such as GPS and other applications, how this particular deep learning application can be exploited. So on. And caption generation, other type of problem we have. I simply take some vision, some deep signal plus some language generating RNA. You know how we use RNA concepts and all, you know. Then you're going to generate, first of all, a group of people are first you're going to identify the objects, then the purpose, and so on. So you're going to make the caption of particular image based on the objects identification and the other feature extraction you are going to make. Okay. Then you have speech recognition. That is one of the, like I said, you're going to make the input images and you're going to call the emotions, or you can say the actions, or what you call your footprints, whatever it is. Then for a given shorter time interval, and you're going to make them analyze at a particular time interval and see what could be the possible word, possible sentence, possible para the person is likely to do. The many of the existing architectures are there. LibNet is there. This is the first end-to-end sentence level model that is used to make such a type of vocabulary to identify based on some visual features. Okay. Similarly, many are there. These type of things will be very useful, and even text to read conversion also will be there. If I upload a text and you can simply read it, you need not to read it. Simply if I upload a text image or a URL, it will read this. The application will read the entire URL or entire web page of the URL that you have uploaded. Okay, people are achieving around more than 95%. So we are going in the right direction of going with this particular application. Similarly, nowadays you see many of the e-commerce companies and other type of organizations, they are dealing with drones and drone delivery. Okay, drone delivery and so on, so, and then manipulating the what you can say, analyzing the paths of the drones and the real-time analysis you're making, real-time surveillance system for defense application and all. Okay, so how this particular drone can automatically, because you can't give a real-time instruction. Whenever it's a real-time monitoring, you can't give a real-time instruction. Human can't. That's why I say in the first slide, Humans can say layer computation, layer learning. So there will be some time, after some level, they can't learn, even though training is given. Wherein, whenever I say real time learning or real time monitoring, the drones can, you should make a real time learning or real time processing of the given input image or the surveillance image of the drone, and then that can be processed. If you see the figure, we have a deep neural networks with some control signal. Wherever it is captured, and you are going to take decision, move left, go straight, turn right, based on some feature values, and the image is captured real time. Okay, the faster the network, the faster the drone can fly, right? How fastly the network can be processed, the input features and the CCTV image are not CCTV, the camera of the drone, and accordingly the signal can be processed and classification can be done. Okay. Similarly, other type of neural computation modeling we have with this type of deep learning architectures. If you go into biomedical type of architectures, we have neuromodulation. And if you see how the millions of billions of neurons work together, and when the spinal cord process the information, we try to fetch all the information with the spinal cord, and spinal cord gives to the motorist receptors. How the central nervous system, how it works when you're writing an examination. When your eyes see the question paper, then it will read it and give it feed to the human brain what the question is. It will be processed in the central nervous system. The answer is within your brain, and your central nervous system via the spinal cord will give an interruption to the muscle receptors, where the muscle receptors carry forward the information to the fingers, and fingers will write the examination, right, with a pen. So that eyes and ear, maybe eyes are the sensory organs, your fingers are the motor organs, and the central nervous system will act according to the sensory and motor organs, like. So this is a cyclic process. You keep on writing and you keep on getting the interruption from the spinal cord via the neuron cell information. So the neuromodulation, basically what will happen when there is an injury or something happen to the spinal cord, you are trying to develop some deep brain stimulation, make an artificial implanted chip inside the human body, where the electrode is connected to the human brain, where the signals are being captured, and accordingly the kind of the signal delivery can happen. Okay, this deep brain stimulation will be useful to make some kind of paralysis person or epilepsy, stroke person to work normally according to the requirement. There is some side effects with this one, of course. Okay. And then there is another type of deep brain stimulation we have, transaction magnetic stimulation, where we try to make some magnetic impulse to ease the depression, where we are going to fight against the depression by just projecting this type of magnetic pulse onto the particular region, which is actually responsible for the dullness or drowsiness, or you can say depression and so on, so giddiness, whatever it is. So you can collect the data recursively or iteratively in a real-time mode and try to see what type of analysis you can make and see whether person is improved or not. The disease can be cured or not by taking real-time data signals. And similarly, we have some neural processing and neural rehabilitation application. You can use some deep learning architectures by taking some data. If you see there is a missing link present, in the figure. The missing link, when the muscle receptors carry forward the information from the interruption of the neural signals, whenever the data is not going forward because of the missing link, you attach the electrodes and try to capture the particular data, EEG or fMRI or EMG data, whatever the signals you have. Then feed those signals data to some Raspberry Pi or microprocessor, any microprocessor, microcontroller, Arduino or Raspberry Pi. But you just make high-end processor that will carry forward the information and then process them in a real-time speed. If one person is moving his left leg, with same speed the right leg should move. It is not like the 2 times left leg move, 1 time right leg, the person will fall down. So the real-time processing of the particular device, the neural processing device that you are making should have a real-time architectures. Okay, real-time devices, and you need a faster device, a faster communication. So, but at the same time you require accuracy. So how many layers you are going to have here, how many layers, and how the features are extracted, what are the features, all those things you are going to consider here according to the requirement of the device that are moving. Similarly, retinal implants we have there, and if you know when there is a problem with the vision of a particular person, you know how the vision, whenever retina captures the image, the cornea will look into that, and the particular information is stored in the optic nerve, where the optic nerve is directly connected to the human brain. When it is connected to the human brain processes the information that is captured by the cornea and the retina images. Okay. When there is such damage happens, there is a fixation of the cable or the particular artificial chip which you are placing to capture the image. There is artificial lens maybe even that is directly connected to the optic nerve. When the optic nerve is directly connected to the human brain and the artificial images that are captured in the particular lens and the chip that is carry forwarded to the human brain. This is a prototype they are trying to design. This type of retinal implants are trying to be very useful. Okay. So all these type of applications we can derive with the help of the deep learning application that you're trying to solve for the desired selected problem. Okay. Still, there are all kind of what you can see. There are all kind of deep learning applications which you're trying to propose with the help of which. Okay. I think we have seen many. Now, if you have any doubts, let me know. We have about 10 minutes time.
Yeah. Thank you, sir. Thank you for your acceptance and giving the scope of research which is possible in the particular context,
Yes.
especially the possibilities of continuing their research in the deep learning domain. Now I am requesting the participants to clarify your doubts with the resource person. So already one person typed in the chat box. They're asking for deep learning we need to have the huge amount of the data as it is.
Yes.
So what are the main points to be considered while doing the training for the deep learning approach with the size of the with the huge amount of the data set?
See, whenever I say huge amount of data, first of all, try to understand. It does not mean that your what you can say input layer of the deep learning should be preloaded with a large number of what you can say features. When you have a particular data, maybe see nowadays we are doing all many of the big data analysis applications. If you see many of the big data analysis data, we have petabytes and hexabytes of data. So we can't use all the dimension values or the feature values in the layer of the deep learning. Let it be some other any even conventional neural models also the same thing is true. But in case of deep learning architecture, when you require large amount of training to the particular model, what you can do, you can train it phase by phase. You can see you just take maybe some 1/3 of the data, train your model, the remaining portion of the data, other portion, train your model, and or you can say simply see when you have shortfall of data, there is a problem. When you have extensive data, simply you try to use some optimization algorithm, extract the better features, and preload these features to the input layer of the deep learning. And next time you take different set of features, different combination of the features, because there will be many permutations of the features possible. These features values will define the notion of the classification. When you have the shortfall of the data, then what happens? You can add some kind of additional data and try to run the different package. But when you have large amount of data, take features of different permutation and try to use and see in which particular case the classification activities. Accordingly, you try to train your model. Now there is another question: how many dimensions should be enough for moving forward with deep learning? It depends on the data you are dealing with. It depends on what type of application you are trying to solve and what type of data you are dealing with. We can't easily say particular number of dimensions are enough to deal with. It depends on it. Maybe if it is a maybe a high performance computing application that you are trying to solve using a deep learning architecture, you might require more and more dimensions. Challenges of deep learning. Challenges in deep learning could be mainly what happens. First and foremost challenging is to deal with the features, which particular features you are trying to. For example, you're using autoencoders. When you use a stack of autoencoders, what will happen? You are making the dimensionality reduction. When you don't find the better features and always you are extracting the features, the classification accuracy finally will be happening, and you may not be able to find the minimum performance out of the expected. First is feature extraction or feature selection. Next is minimizing the number of hidden layers. Next is selecting the suitable aggregation and activation functions. All they are the challenges in deep learning. Any other doubts? How to integrate machine learning and deep learning? See, you take some existing machine learning model, something like some evolutionary computation such as BAT, binary BAT, or any other type of nature computing model in machine learning. I want to integrate with some deep learning. First of all, you see what type of data is ready with your deep learning architecture. I want to integrate with some machine learning such as some binary BAT optimization algorithm. Now, whether this can be adaptable or not. See, any machine learning model, first and foremost, you have to see the adaptability. Whenever the model you are selecting is not adaptable, for example, you see ad-call optimization algorithm, it cannot be adaptable to every computing problem or maybe. See, in ad-call optimization, what we have a group of vertices, we have a group of edges, like a group of ants and group of paths. So whenever you have a group of paths and group of ants, or you can say group of vertices, such a type of architecture in machine learning could be suitable to problems such as what network coverage, routing, set cover problem, and so on. So when you have such a type of adaptability is there, then you can integrate. So the main reason for combining deep learning with any maybe evolution competition, whatever it is, you should be adaptable to this particular deep learning architecture. You have to see the adaptability. For that, you have to see which application you are working on. Any other doubts? Next question is, how much efficiency can be achieved for object detection by AI? People have started around, I think, 1994, 95, I've seen the massive spark. But again, this is a tricky question. It depends on if you give a complex image, the same model. For example, the main problem with this type of research is, I will develop a model, then I'll use some benchmark data set. I will say that this based on this data set accuracy is 95%. Now, when you use typically even more complex data set, you may find a lower accuracy. Okay, so normally in the benchmark data set we have seen about 94-95% accuracy. Okay, but if even if you give complex images, it will change. So now how to say that yours is better? So what you can do, you can develop your model and try to use on same benchmark data set where somebody has claimed 94% accuracy. As that, you try to prove at least 1% extra, so that you can claim that you have all the features of there and yours is some 1% extra there, something like that. That's why we always validate our research on benchmark data sets. Now there is another question: will the feature reduction or feature selection create an impact in the number of hidden layers? May not be much, because basically the ultimate job of feature extraction or feature selection is to find the better classification accuracy. So when you go for a number of hidden layers identified, sometimes it may be, but it need not necessarily always. But of course, it will definitely affect the classification accuracy. Number of hidden layers, sometimes it might. Any other doubts? Any other doubts? You can ask any general queries also. Any other doubts you have related to any other paper publication or any SCI journal, Scopus, PhD, any other. I'm free to take any doubts. I'm open to take any doubts.
Yeah, dear participants, now it is open platform for to clarify any doubts regarding your research, any projects related questions, anything you may ask. Uh, you can unmute yourself. Otherwise, please type in a chat window your question so that sir will answer for the question. Better feature selection methods they're asking, sir.
Better features. See, we have seen BAT and bind the BAT were working fine. BAT and bind the BAT optimization algorithm for feature extraction and feature selection. You try with that, and if you want many, I have some of the existing. There is one URL from some, I think, NTU or some university, where they have given the codes of a lot of existing feature extraction algorithms and all. If you want, I can share it. Maybe later on you can mail me. But maybe you can try with BAT and bind the BAT and other type of optimization algorithms. Particularly biosphere optimization algorithms. They could be very useful for this type of problem.
Thank you, sir.
Any other doubts? No more doubts?
Yeah.
No, what I suggest, don't just remain satisfied with deep learning. Whenever you have a highly computationally expensive data set with you, expensive is the expensive deep learning models, you can alternatively select a ELM also, extreme learning machines, or online sequential hierarchical extreme learning machines, they are actually computation efficient compared to deep learning. But these extreme learning machines and the concept of ELM was very nice. Actually, that includes more features of the deep learning, and it has a single hidden layer, you can say, and its accuracy is somewhat lesser than deep learning. For example, if there is a data benchmark data, if your deep learning gives around 94% accuracy, extreme learning machine, it includes almost every feature of deep learning, but the accuracy would be slightly lower than deep learning. So there could be slightly lower accuracy, but it's a better alternative to. So if accuracy is not a serious issue to you, computational efficiency you are mostly focused upon, you can select ELM in place of deep learning approaches. That's all. Just I wanted to add a point. Any other doubts? Shall we close for today?
Yes, sir. Thank you, sir. I think no more doubts from the participant side. We, yes, we'll conclude the session, sir. Um, yeah, thank you so much, sir. Thank you for sharing your greatest knowledge with the participants. Thank you once again.
Thank you, madam. Thank you. Thank you. Also, I would like to thank the department and the head of the department and everyone of your college for giving me the opportunity. And I would like to personally thank Dr. Srinivas sir, who is always doing communication with me, and he's always supportive, and he's a good friend of mine. I'd like to thank each one of the department, and in future, if you have any, if I could be of any help, if you need any information or any data sets or any type, you are free to help me. Not only the organizers, participants, and everyone. Okay, I'll be happy to help.
Yeah.
Next.
Thank you. Thank you for your kind words and the thought of sharing your resources with the participants and organizers also. Thank you for your kind nature.
Thank you, thank you, thank you. All the best to all of you. Thank you.
Yes, that's about today's session about scope of research in deep learning. Thank you once again to Dr. Damodar Reddy sir for taking up this session. Thank you once again. Participants, now will take a break for lunch, and after lunch afternoon we'll start. There will be a valedictory session from 2 to 2:30. So we are going to post the online assessment exam link at 2:30. Exam will be from 2:30 to 3:30. Link will be opened till 4 o'clock. So you can go with your exam from 2:30 to 4 o'clock onwards. There will be 20 multiple choice questions. So it is mandatory to issue the e-certificate, 80% attendance and 60% score in the online assessment test. It is mandatory to generate e-certificates to all the participants. So I request all the participants, please fill out the attendance and feedback form link for forenoon session, and even afternoon session also we are going to forward the link for overall feedback form for this STTP. So you have to fill overall feedback form link as well as you have to write the test. That's about the schedule of the afternoon session. Thank you. We'll take a break for lunch. So we'll be back at 2 o'clock for valedictory session. Thank you. Sir, exam is from 2:30 onwards, sir. 2:30. Afternoon, 2:30 p.m. onwards, there will be online assessment exam.